Hello, welcome. Let's try to solve another Leetcode problem 2857 called pairs of points with distance k. So for this problem, we are given a coordinates. So the coordinates are going to be an array of coordinates points. So for example, we have this coordinates array, and inside it's going to be such points. And we are also given an integer k, and all those points going to be the coordinates of the 2D plane. So we define the distance between 2 points, x1, y1, and x2, y2 as the XOR operation. So basically it means x1, XOR x2 plus y1, XOR y2. So where XOR is the bitwise XOR operation. So we're going to return the number of pairs ij such that I less than j, and the distance between I and j is equal to k. Basically it is the XOR operation. So in this example we can find two possible cases. It's going to be index 0, 1 and index 2, 3, as we can see the formula. Yeah. So basically 1 XOR 4. So what is the result? It's going to be 5, and 2 XOR 2 is going to be 0. 0 plus 5 is going to be 5. 1 XOR 5 is going to be 4. 3 XOR 2 is going to be 1. 4 plus 1 is going to be 5. So we only find two pairs. So this is why we're going to return a 2. Yeah. So if we solve it directly using the brute force, definitely it didn't work, because the length of the coordinates array is 5 times 10 to the power 4. Definitely it didn't work. But let's just check the formula. So the formula is x1 XOR x2 plus y1 XOR y2 gonna equal to k. So this is the formula. So here I'm gonna use a single equal because it is the same. Yeah, x1, y1 is one of the coordinates, and x2, y2 is the other coordinates, and this is the formula. Yeah. So if the XOR formula meets the conditions, how can we deduct? Yeah, because x1, x2, and y1, y2 gonna always be more than and equal to 0. So this is the property of the XOR operation. It's gonna always be more than 0. Yeah. So this means x1 XOR 2 gonna be more than 0 and less than or equal to k, and it can never be more than k. Yeah, because this is some number more than or equal to 0, and this is some number more than or equal to 0. So this means this number gonna be the range from 0 to k. Yeah, and similarly for y1, let me just copy it. Yeah. So this is the range of y1 and y2. Now, what do we get? So let's just check if we set x1 XOR x2 equal to I, what's going to happen? Yeah. So if x1 XOR y2 equal to I, how can we deduct? It means x1 gonna equal to x2 XOR I, and similarly y1 XOR, yeah, let me just think about it. Yeah, from y1 XOR y2 gonna equal to k minus I. Yeah, because this is k and this is I. x1 XOR x2, this is I, so y1 XOR y2 gonna be k minus I. Yeah, so from this one we can deduct y1 gonna equal to y2 XOR k minus I. So as we can see from the formula, x1 gonna equal to something x2 with XOR of I, and y1 gonna equal to something y2 XOR k minus I. Yeah, so this means we can just enumerate all the possible cases of x2 and y2, and then we can get the result. And for this k and for this I, we just need to enumerate all the possibles of I, and this I gonna be in the range from 0 to k. So this means the final time complexity gonna be n times k, and k gonna be 100 according to the problem. Yeah, actually if we are checking the length and this k, maybe, yeah, because this is k is really small, maybe the time complexity is k times actually it is. Yeah. Now we just need to use those two formulas to get the final result. Yeah. So this is the first formula. Yeah, and we're gonna combine with the first and the second formula to solve the problem. Yeah. So this means we just need to enumerate all the coordinates, all the points. Yeah, and then we just need to check if there's something like this one, x2, x or I, and y2, x or k minus I. If it is inside the hash table or not, we're gonna use a hash table to check, or we can use a counter directly. So we're gonna use a counter, and we're gonna prepare the final result. And then we just need to check all the possible coordinates for x, y in coordinates. Yeah, and the result gonna plus equal to. And first of all, let's just check the I. So for I in range k plus 1, that's gonna be all the possible cases of I. And let's just update the result. It's gonna be d with this one, x or I. And y x or k minus I. So after all those checking, we're gonna update the result because we finished the first point. It means d xy. This is a c xy gonna plus equal to 1. So finally, we're gonna return the result. So this is just similar like to sum. Yeah. So basically, for the first case, we didn't update anything, and then we finished the first point, this xy. So for example, this x2, it has already been recorded in the dictionary. And now for this 1 and 2, yeah, because this 1 and 2 is inside of the dictionary, and for this x and y, we're gonna continue to check for the second one. This is x and y, and this one has already been stored in the dictionary. And for this 4 and 2, we're going to enumerate all the possible cases, and we're going to check x with x or I and y x or k minus I. So if this tuple is inside the dictionary, if there's a value, so we're going to update the result. Yeah, so this means basically some value equal to x or I, and some value equal to y x or k minus I. Yeah, this means this coordinates equal to some previous coordinates. Yeah, so this is this xy is the current coordinates, and for this calculation, we just need to check if it may equal to some previous result. This is the previously stored result. Yeah, and we're gonna update them. Yeah, so if we have more equal values of x and y, we're gonna update them. Yeah, so for example, let me use example. For example, 1, 2, and 4, 2 is a possible case. Yeah, maybe after some time we have another 1, 2. So this means from here we're going to update it, so it's going to become a 2. Maybe after some places there's another 4, 2. So how many? How many cases? So this is a 1, and for here we have another 1, 2. Yeah, so this 1, 2 with 4, 2, it is another 1, but this 1, 2 has already updated to 2. And so for this 4, 2, it is a plus 2 instead of a 1, because we have 2, 1, 2. Yeah, so this is why we're going to start it like this. Now, yeah, maybe let me just print what it looks like for this dictionary, and it will be more clear to understand why we're going to write it like this. So this is a counter. Yeah. So as we can see from the beginning, let's just check the coding. Yeah. As we can see from the beginning, we just started this x and y for the first coordinates 1 and 2. It is inside a counter, and the counter of 1 and 2 is 1. And then we're going to check the second case. So secondly, we're going to put 4, 2 inside, so 4, 2 becomes 1. And for here, we've already updated because this one, x or I, and this y, x or k minus I. So definitely we can find one of the cases. So it is 1 and 2. If we find it, we're going to update the result. So this is why this is very important. We just need to check the range for I from 0 to k and check all the different cases. So definitely there's one possible case. We're going to update the result. and then we're going to put it inside the counter, and continue we're going to put this one inside the counter and this one inside the counter. Yeah, so this is why we're going to always solve it like this. But as you can see inside the second example, yeah, we just need to update the value because the coordinates is always the same for 1 and 3. As you can see, 1 and 3 it is 1, 1 and 3 it is 2. Yeah, but for each of the updating, we should know that the result 1 and 3 XOR another 1 and 3, so it's going to be 0. So this is why it's going to be 1 plus 2 plus 3 plus 4, it's going to be 10. So this is why we're going to write it like this. Yeah. Now let me just submit it to check if it works. As you can see, it works, and I think the speed is basically okay, and because the time complexity is n times k. Thanks for watching. See you next time.